Hi, everyone. Thank you for joining us today for this panel discussion on building and managing the modern data store, the Data Lakehouse. I'm Priyanka, and I will be your host for this webinar. Before we begin today's session, I would like to remind you of a few things. All attendees will be on listen only mode. You can type in your questions anytime during the panel discussion in the Q&A window that's available on your screen, and we will address them at the end of the session. Let's begin with a quick overview of Hebo. Hebo is a no-code data pipeline platform that connects and loads your data that's lying across multiple source systems into a data warehouse of your choice, such as Redshift, BigQuery, Snowflake, and others. Hebo provides pre-built integrations with over 100 different data sources and also supports advanced data transformation. Hebo is currently used by thousands of data enthusiasts who are working across multiple verticals and who are based in over 40 different countries. For more information, you can check our website www.hevodata.com. So let's begin the panel discussion. I would like to start by introducing our moderator for today's session, Paul Morley. Paul Morley, in his ownership role of NetBank's Enterprise Data Services, leads a team of world-class data professionals and is responsible for delivering NetBank's regulatory commitments to the various regulatory bodies that govern the financial sector. He is also principal in delivering data analytics services to NetBank's business clusters. With almost 30 years of experience in IT and data with IBM and NetBank. Thank you, Paul, for joining us today. Here's a little bit about our esteemed panelists. James Serra works at Microsoft as a big data and data warehousing solutions architect. He's a thought leader in the use and application of big data and advanced analytics, including data architectures such as the modern data warehouse, data lakehouse, data fabric, and data mesh. Previously, he was an independent consultant working as a data warehouse and business intelligence architect and developer. He is a prior SQL Server MVP with over 35 years of IT experience. He is a popular blogger and speaker, having presented at dozens of major events. He is also the author of the book Reporting with Microsoft SQL Server 2012. Thank you, James, for joining us today.
Sure, happy to be here.
Devo Sinha is a senior solutions architect at Databricks, focused on implementing and optimizing machine learning and deep learning capable pipelines at scale. In his current role, he interacts and aligns strategically with the technical and business leadership of Databricks enterprise customers. He's leveraging his strong technical background, love for public speaking, and effective communications with customers to understand their business, technical strategies, and challenges. As a senior solutions architect at Lifion by ADP, senior engineer at V12 Group and Bank of America, he has spearheaded multiple projects involving streaming and machine learning capable pipeline creation and optimization. Thank you for joining the panel, Debu.
Thank you so much.
Raghu Nandikanti has been building very large-scale enterprise data warehouse, data lake, and data lakehouse data integrations and data engineering teams in the cloud and on-premise for 17 years. He currently manages the enterprise data engineering platform team at Red Ventures. He is a pioneer in digital marketing with a mission to help millions of people make some of the most important decisions. Before joining Red Ventures, Raghu worked on several leadership roles at Belk, Emerin, Premier, and Bank of America. Thank you for joining us, Raghu.
Thanks for having me here.
Akash Malve is currently the principal data scientist at iCertis. Akash brings about knowledge of natural language processing, deep learning, and artificial intelligence, especially using Bayesian and GAN approaches to AI. Akash is passionate about enterprise solutions and has more than 25 years of experience in SAP, business intelligence, and artificial intelligence. Akash extensive has played a role has played various roles like architect, CTO, and chief data scientist. He has worked extensively with Fortune 500 customers like Honda, Xchara, and Reliance. Welcome, Akash. So thank you, gentlemen, for joining us today. I'm just going to add Paul back into the session. Yes, Paul. Yes, Paul, you're in the session now. You can.
Thank you very much, Priya, and welcome everybody, panelists. Great to speak to all of you again. And without further ado, let's talk about this new thing, this new debate we've been having, this new architecture. Everybody's on this point. I'd like to start off with Debu. Debu, so tell me at a level, why is this new architecture so important, and how are these benefits so much different to what we have in a traditional space?
No, absolutely. Thank you, Paul, for asking about this question. So before I go into the benefits, like it makes sense for me to take a step back and talk about the evolution of the data lakes and the warehouses and why Lakehouse is so important. Like we can come back to that. So data warehouses, as we know, were introduced 40 years back in the 1980s. They were purposefully built for BI and reporting, and they were great for it. However, they did not support many of the unstructured data sets like video, audio, text data, and also the semi-structured data sets that we have today. And many of the organizations, like when I work with customers, like most of the data in the organizations now belong to such different categories that cannot be fit into a relational database schema. So as a result, it was really hard to do machine learning on the data sets that are stored in the data warehouse. Also, they have a very limited support for real-time streaming, which is also becoming increasingly important for many different types of industries, be it healthcare, like IoT companies, like this is one of the bread and butter use cases. You have streaming data coming in, you want to perform predictive maintenance or analytics on top of your data and provide real-time input to your machine learning models. And ultimately, with the traditional data warehouses, one more drawback is that they use proprietary format. So your data is actually logged into your data warehouse. And if you want to perform any sort of machine learning on top of it, you have to either take that data out of your machine learning data warehouse and make a copy of it. So it essentially adds to the cost of maintenance. And data warehouse by itself, for very large data sets, they are very costly. So with that, around 2010s, the concept of data lakes emerged to tackle the challenges of the data warehouses. So the idea was to have a one central scalable, durable storage like HDFS or maybe blob storage like object store like a S3 to store all the data in your organization. And ultimately, that storage can have now your structured, semi-structured, and unstructured data sets. You can power your streaming use cases as well as machine learning on top of it. And lastly, it used open formats. So most of the data lakes in the past years, we have seen they are standardizing on Parquet format. So that has become the standard. And now many tools which want to directly interact with these data sets sitting in your data lake, they can directly query the files and they are not tied to a certain format or type of language. Like they can use either Python, R, or whatever language they are comfortable with. So this was the benefit. However, the data lakes itself didn't turn out to be efficient for traditional BI use cases. And the performance was really bad. So traditional data lakes, like they were really bad for any transactions. They lacked any fine-grained access control and governance, which are really important when it comes to, if you're coming from the data warehouse world, there will be a shock because it is very hard to implement the bread and butter governance on the data lakes. So ultimately, what ended up happening is at Databricks, when I was working with multiple customers who are starting out their journey, they created their enterprise data lakes, but ultimately they realized that they cannot really monetize it or they cannot utilize it to the full potential. And most of the use cases were failing. So as a result, many of the data lakes, which had a promise of becoming really these ultimate golden single set of truth, where you can now do your machine learning, your AI, and predictive intelligence for your use cases, turned out to become data swarms because no one can really get any value out of it. So actually, most of the data now sits inside the data lakes. Like 90% of the data sits inside your data lakes. And there's a company which is very successful, like Snowflake. It's a very successful data warehouse. So about 250 petabyte of the data is under their management. This was their official number. Whereas in Databricks environment, like we have seen that some of our customers have a single table with that kind of data. So in today's world, the architecture is a bit of a hybrid. You have the central data lake that holds all your data, whether structured, unstructured in your organization, landing into your data lake. And then from there, you take a certain fraction of your data, that is your gold data sets, to furnish your or service your BI workloads into the data warehouse. So this is the modern day architecture.
Yeah, so Debbie, so that's so if I'm understanding it correctly, I mean, that does talk about some of the benefits of how it's different. So, you know, if I have to summarize what you're saying there, that it is about aggregating different data types and making sure that it's presented to the consumer or put in a place for consumption by a consumer in a very agile sort of method an approach to normalizing a process for data consumption. Is that how I read that from you?
That was the purpose of the data lakes. But there is another thing that the Lakehouse really brings together. You got it, Paul. Like the benefit, Lakehouse came in because it's a very simple concept. Like many of the big data companies like Netflix and others, like the really good companies in the past, which were born out of data, and they have these processes, same platform to service all their BI and like ETL workloads, all from single platform. But so Lakehouse concept is essentially bringing the best of both worlds together. You get the governance and the data quality, like the access control of and performance and indexes of the BI world or the house part. And then the lake part gives you that extension and support for machine learning, as well as the support for open formats. And you have a single store where you can now have that interface and query. So now,
with as everything in life, everything has a trade-off. So where's the balance for a Lakehouse versus everything else? What are the trade-offs? What are the capabilities we need to sacrifice to improve other dimensions? So what are the trade-offs? Like governance, for example. How does this affect governance? How does this affect security, etc.? As an example, what are the trade-offs that a Lakehouse brings to the table?
No, absolutely. These are some of the great aspects. Like when data lakes failed, like one of the key issues with data lakes was the governance part, right? Because now your data is unstructured. So how will you actually make sure that the right people in the organization have access to the right data and also the right subset of the data? So Lakehouse has come a long way from where the data lakes stopped. So Lakehouses have an additional metadata management layer or a performance layer on top of them that provides you with a lot of governance features and the benefits of the data warehousing world. Like this metadata management layer that I'm talking about, management and performance layer, in Databricks world, it's like the Delta Lake platform, right? So Delta Lake, when you align your data lake at the bottom, your data is still stored in your data lake. On top of that, that management and performance layer data of Delta Lake provides you with a lot of benefits. Like you can index your data. In terms of performance, you have a lot of optimizations around how your data is actually queried, the metadata is stored. And in terms of costs, because now that performance layer is actually giving you interface, like a single interface for your BI as well as your ETL workloads. It kind of simplifies the architecture, and your cost is reduced. Also, it provides asset
Thanks a lot.
Okay.
Thanks, Debbie. That's great. We are pushed for a little bit of time. I am going to like to move on, but yeah, great insights there, Debbie. And I think those are some of the benefits that people can deal into. Now, moving on, I'd like to go over to Akesh. Welcome, Akesh. And I know you're a little bit of an expert as well in this field. If I can just remind everybody, we need to keep it short. We will be under time pressures if we continue. Akesh, can we move on to you, Akesh?
Yes.
Welcome.
Yes, thanks, Paul. Thanks, Priyanka, for inviting me. So
always a pleasure, my friend. You're a little bit of an expert in this field. I would like to kick off with everybody always asks this question, and sorry to put you under pressure on this one. Cost. What is the real cost of a lakehouse warehouse? Where does the tie hit the tar on cost on a lakehouse? Akesh, over to you.
Sure. So I think what I have seen working, I happen to work with startups as well as large enterprises, and everybody is looking at different challenges actually, because 20 years ago, people were working with pure data warehouses with product like Teradata. It was a big bang approach. So you spend anything between 1 year to 2 years in just building the data warehouse, and another 9 months to 1 year to start getting some kind of business intelligence or analytics from them. Okay. Now, from those days, things have really changed because startups are starting from analytics and, as Debbie mentioned, monetizing their data from day one. Because the challenges startups have, the new age large enterprises have, they want to monetize the data. Now, this is a big change. And today, what I'm seeing is people want their single version of truth. And I will put two concepts here. See, business intelligence was only internal data, but external data about organizations, customer data platform, marketing data platform, all of that data right now is available on cloud. Putting everything on cloud, making general purpose hardware driven cloud storage objects, and creating a single version of truth, and then running both analytics workload as well as BI of the old school and AI of the new school. So when I say AI, I generally combine data science, machine learning, and AI together. So these are the two concepts. I repeat those concepts again: internal data, which was only business intelligence; external data, where data coming from cloud data platform, marketing data platforms, and combining business intelligence with artificial intelligence. All of that is only possible with architecture like Lakehouse. Okay. And you asked about trade-off, Paul. That was one of the questions I think Debu answered at some level. What I feel is the real trade-off is, as we move on, due to cloud and due to availability of lot of data, eventually companies will spend more on the data lakehouse because it is all cloud-based, but the ROI around that will be much higher than the conventional data warehouse and the conventional business intelligence and the conventional pure data lake. So really, businesses are looking at data as their intellectual property, as a property on which they can monetize, they can earn money. The business models, the startup, the unicorn, even the smaller startups, the whole business model is built on the value of data. And in olden days, maybe 10 years ago, having data warehouse, business intelligence were nice to have things. Now that is a real dramatic shift, where you are building a business which is data intensive, and you want to combine external intelligence versus plus internal intelligence. You want to combine BI with AI, and all of that right now is only possible with Lakehouse kind of architecture.
That's great. I think that's an important concept. Is one of the big benefits is the ability to integrate into all these different, should I say, data domains, if you will, be it analytics, machine learning, data science, etc. Now, you tell me a little bit more about, in your experience, because I know you've got some experience in this side, is what are the companies in the broader industry doing about adopting this architecture? And you mentioned some startups. So what is the more traditional?
Now, compliance, data security, GDPRs, data privacy, ability to really, hide data, ability to not give complete version of truth to anybody who's, querying the data lakehouse. All these are very important factors, starting from the biggest industry, which is like BFSI, banking, financial services, insurance, and securities, where data privacy, data security, compliance is big. Another industry is healthcare, where really protecting the healthcare data. There are various laws and acts like HIPAA and so on. Now, really addressing all of that compliance dimension from a building of data lakehouse is one of the bigger challenges which every organization is going to face, because on a data lakehouse, everything is on cloud. Now, there was resistance few years ago about putting everything on cloud. Now, more or less, all those problems are solved because the hyperscalers, be it AWS, Google, Microsoft, IBM, Oracle, all these companies have somehow solved the data security problem on the cloud at a level where businesses are comfortable. But I'm still saying the real challenge comes in building a secured, traceable, auditable, compliance-driven data lakehouse, and then running your analytics and workloads, your data science, machine learning, and AI workloads on top of it. Now, this is a real big challenging area. What I've seen is companies are right now still trying to utilize the tools available like Hebo or Databricks. Google has recently launched Big Lake. So BigQuery was their last product, competing with Redshift. Now they have launched Big Lake. Big Lake again allows you to do a lot of things which are available with modern data lakehouse. So I think those are some of the challenges every industry will face, which I have personally faced. We were working with one of the largest healthcare providers in the US. They are one of the largest private hospital chains. Data, availability, managing the data, data security, compliance, these are one of the challenging areas.
Awesome, Akesh. Always great insights, and yes, I think there's a big move towards cloud, and people facing the problems that you've mentioned are well known, and this is one of the places a data lakehouse can play. Now, again, limiting to time, I'd like to get everybody's views. Akesh, thank you very much. I'd like now to welcome Raghu. Raghu, if you don't mind, also some tough questions. So let's talk about, we've talked about cost and where that fits in. Now let's talk about performance, okay? Has always been a big issue in the data landscape, in the data ecosphere. Always been a big bugbear of data operations across any enterprise. Now, how does a lakehouse help support a modern data operations? Integration, monitoring, provisioning, stability, retention. How does a lakehouse play a role in solving the problems that keep the operations folk awake at night?
Yeah, thanks, Paul, for the question. So performance is, as you said, is a key for data lakehouse to become prominent in the main data architecture used by many companies today. Performance is one of the key reasons why we had like data warehouses to be exist in two-tier architecture. We had data lake and data warehouses in two-tier architecture. So the performance is the main reason for having warehouses because even though data lake uses low-cost object stores, accessing data was slow in the past, but the new query engines are helping to bring the high-performance SQL analysis on top of data lake. So this combining these two technologies together, Data Lakehouse is solving the problem. So there are some optimizations that we can use, like caching hard data in memory, data layout optimization to the cluster, co-access data, and cost efficiency using like high performing CPU, thanks to cloud, which is available at like lot cheaper cost than previously. So combining all these technologies together enables data lakehouses to achieve higher performance on large data sets compared to traditional data warehouses. And going to the other question that you asked, how can you ingest the data? You can ingest the data in several ways into the lakehouse. You can stream the data in real time. You can replicate the data from transactional data warehouse databases in real time or near real time using log analysis. And we can build a batch data pipelines as well, similar to how we ingest the data into data lakes today. And the main thing is, right, the main difference is you can upsert the data into the data lake house, which is very challenging in data lake. Data upserting was not a use case in data lake. And other point you touched on the monitoring side. Building a monitoring capability is critical for success, not only for data lake house, for any data products that we build. So we need to make sure the data is not lost in the travel. So especially for real-time data processing, that is very critical. So we usually build a replay mechanism to reprocess the data in case of any outages or any kind of data loss. So features like audit history, time travel, these are helped like faster data recovery and provided auditing capabilities out of the box from data lake houses.
So performance. Let's talk specifically about. I would like to unpack a little bit about the performance again that you haven't covered. What is specifically about performance that makes a lakehouse stand out from other architectures specifically?
Sure. Yeah, the data lake house systems are like built around separate elastically scaling compute and storage systems to minimize the cost and maximize the performance. So the main theme here is separating the storage and computing into different workloads. So recent systems provides comparable or better performance per dollar to traditional data warehouses for SQL workloads. And we can use the optimization technique like query compilation and storage layout optimization. And in addition to do that, right, we can use spot instances to process the data, which reduces cost significantly. And we can move infrequently accessed data to lower storage system, cheaper storage systems for further cost savings. And going back to the performance improvements, right, like it enables like, we can use data like Spark data frames to provide declarative interfaces for the open formats, which enables further reduction in IO and enables like IO optimization. And since we are using data lake house, we don't have to run multiple times a day the complex ETL processing to load your data from data lake to traditional warehouses. So that is another aspect of like advantages of using data lake houses.
Now you've mentioned an aspect of this before around the patterns, the new patterns, hyperscale, elastic storage, massive compute brings around patterns. I mean, that is a significant pattern that's going to achieve many benefits for organizations that use it. Now, the challenge always comes in with these types of architectures is how do we move to a lakehouse from a legacy perspective? How do we transition from old to new? How do we take benefit of a lakehouse when we stuck and grounded and dragging legacy behind us? How do we move from the old to new? What are the patterns and approaches one can adopt to make this an easy journey? Because let's face it, moving to the cloud is a painful experience. Very much so for most, regardless of the architectural approach. There is always a level of uncertainty and disruption that happens. What are the patterns and approaches that one can adopt that makes this journey to the cloud a little bit easier than most?
Yeah, I mean, we can take several approaches in terms of patterns, right? For example, if the environment is multi-cloud or a hybrid cloud or a single cloud approach, right? It is built on open source technology standards. So we are not fixed to any cloud provider, or we are not fixed to any particular vendor. So there is no vendor locking here. So we can go with like multi-cloud approach or a hybrid or single cloud approach. And also we should use the standard software engineering principles like automated build and deployment, versioning the code. These are the best practices that we need to take care when we are deploying this code to production. And like moving from traditional warehouses to data lake house approach, it depends. Like if you already have built a data lake, it is easier to switch to data lake house. You can switch to data lake house by building a structured transactional layer on top of the data lake and building a high performance query engine to access the data using business intelligence, machine learning, or data science teams.
So
Uh,
what I'm hearing is, adopt the standard practices and patterns that we currently deploy today, without getting too fancy. Follow the same patterns as we've always done. Raghu, is that how I'm summarizing what you're saying?
yep, precisely.
Okay, excellent. And I think those are great insights, Raghu. I think we've dealt some big points in this discussion, and I think it deserves a lot more conversation. To be honest, I think there's a lot more time needed to discuss this, because I'm sure I've got 1,000 questions already brewing in my mind. So I could continue this conversation for forever, but unfortunately, we're limited by time on this. And we do have one more guest. I'd like to move off to our esteemed Microsoft architect. I think I've got a couple of questions that I can put him on the spot with, and welcome.
Yeah, sure. Glad to be here.
Great to see you. I'm glad you managed to make it onto our sort of hot topic, and some tough questions. I've left the hard ones for you, unfortunately, if you don't mind. I've put you on the spot here. So tell me, when I look at, I've been in the business for almost 30 years, and I've come from one architecture to another architecture, and I've seen trends go, and I've seen hype cycles move, etc. So is this just another hype? Is this more hype? Is this just another mechanism for us to sell a product, that resell the same product over and over again? Is this another name for a data lake in the cloud? Is this another mesh? Is this another fabric? Because let's face it, hyperscale, elastic storage, massive compute, those benefits are applicable to any architecture in the cloud, and they're not specifically in the domain of data lakehouse. So is this just hype?
No, it's a reality. Nothing is hyped as data mesh in there. The bottom line is there's a number of different data architecture approaches you can take. We have the data lakehouse, we have the data mesh, we have a data fabric, modern data warehouse on there. But I see plenty of customers building a data lakehouse. Microsoft has invested heavily in the idea that I can land data in a data lake and put a Delta Lake on top of that and not have to copy it into another relational database for some of the benefits we saw before. Yeah, there are trade-offs when things like it gets to speed and security and concurrency that you are going to miss out on, or you have to have a workaround. Now, some of those workarounds could be satisfied with a product like Power BI, like row-level security and the performance issues and concurrency and such. But Microsoft sees the benefits of only having to store the data in one place. And I tell customers to look at data lakehouse as do it until you can't. If you run into some of these concerns or issues with a Delta Lake, then maybe a relational database will be an option for you. But plenty of customers have taken that data lakehouse approach and have been very successful with it.
Yeah, that's great. I mean, I think this is just an evolution. I mean, I think to a large degree, a lakehouse is just an evolutionary step of a traditional data warehouse. It's just the next phase. It's not the way I see it. If I'm understanding what you're saying, is it is not in competition with a warehouse. It is an evolution of the warehouse, and that's the take I would take out from what you were saying there. This is the next generation of a warehouse, And now tell me, we always talk about sustainability. Okay, how resilient is this concept of the Lakehouse? Is it going to be around? I mean, let's be honest. The warehouse, the data warehouse concept has been very resilient. It's been around for 20, 30 years. So from that perspective, data warehouse has been a very resilient architecture for many, many years. And yes, all good things come to an end. How resilient is this data lakehouse? Will the data lakehouse be around in 20 years?
The data lakehouse will be around, and I think a data fabric or a relational database is going to continue to be around for quite a long time. It's not anything that's going away in the short term because of some of the shortcomings that have been addressed with Delta Lake. But I go back to 10 years ago when everybody thought, oh, let's put everything in the data lake. We don't need relational databases anymore. And that failed miserably. And now we're at that asking those same questions, but with the Delta Lake addressing some of those problems that we had before with using a data lake, that there are more use cases for a data lake house, but there are going to be plenty of use cases with customers that are going to need a relational database, or if not, a relational layer over the data lake and a Delta Lake. And that may be in Power BI in a data set, and that's your relational layer. Maybe it could be a high metadata store on that, but there always is going to be the complexity with a Delta Lake that you are in a file folder based solution.
Yeah,
and that can be very complex.
I think that's the point. I think that's the point you make. We always see these architectures as competing architectures, and from my understanding is the horses for courses. There are going to be some scenarios and instances where lake houses are beneficial and are required. There are going to be other scenarios where warehouses are required, or for that matter, data lakes are required. And I think, extending to my next question is, why build a lake house? Why not a mesh? Why not a fabric? Your views on that? Because, I think you've answered that question. Is simply there's a place and a time for everything. And it depends on the use case of the organization. That's sort of my understanding. You got a view on that?
Yeah, exactly. As an architect, I do a lot of discovery with a customer and ask them what they're trying to build, what their technology experience is, more detail on their particular use cases, what are the outcomes that they're trying to gather. And then from that, I will then apply what data architecture may work best for them. It could be, and most likely it could be a data lakehouse, but some small use cases could be a data mesh, and a big majority are still going to be a relational database is the way to go, especially if they come and say, look, we don't know anything about Spark. We don't have a data lake. We have a lot of experience, but it's all relational. Then transitioning them to something that's completely radically different may not be good in that particular use case in there. So you really got to clarify, any customers out there, what your current skill set is, things applied that come into licensing and cost and budget. And so you have to look at all those factors and then choose one of these data architectures that's most appropriate.
Absolutely.
And real-time could be a reason for a data lakehouse, because you're not going to go and stream IoT data into a relational databases in the majority of cases. So if that comes up, then okay, maybe a data lakehouse is the best.
Yeah, absolutely. And to wrap up, I think we've covered quite a lot. And to the guests and the panel, I think they've done an awesome job today. I think I've learned a lot. Hopefully our audience has learned a lot. And I'd like to sum it up. Just a couple of questions from my perspective. So what I'm taking out of today's discussion is a data lakehouse is not vastly different to and in competition to any other architecture, being a mesh, being a fabric, being a rational database, for that matter, even being a data lake. That's what I'm hearing. The business it brings to the table is the ability to standardize on consumption of disparate data sets and data sources and data types. It's not constrained by the traditional deployments, the cost, but just a different approach onto the same thing. So this is not an additional cost. This is more of a vector change in the architecture to deploy your cost or your architecture slightly differently from a performance perspective, I think it covers and should meet the needs of most of the operational concerns across the enterprise, especially in the operations domain, and is not vastly different to the operational constraints we suffer today on any other architectural type. It leverages the cloud as core. So the premise behind this architecture is, again, elastic storage, massive parallel compute, and more importantly, this is not an architecture that competes with other architectures. It is not an architecture that is used in isolation of other architectures. It is another option. It is another tool in the toolbox for organizations to deploy based on the appropriate use cases, the appropriate organization demand or need that you have in a particular time. Obviously, a data lakehouse is never going to meet the needs of everybody. There are going to be some companies that don't need a lakehouse. There are going to be other companies that benefit hugely from a lakehouse. So again, this is not a competing architecture, I don't believe. I believe it's just another option, another approach to dealing with the challenges we face in modern data architectures and data enterprises. And sort of that's my summation of today's conversation. I'm not sure if you agree with that, but that's sort of my summation and take out of today's discussion. Thanks again so much for your time, James. Always a pleasure. I would love to discuss this more with you, and perhaps I can reach out at another opportune time, and we can continue this debate, because I do find this conversation very fruitful and meaningful. Thank you so much for your time, James.
Sure, like you, I can talk about this for hours.
Trust me. I mean, I think Priya would have a hard time keeping me in check if I got off if I got into this conversation. Priya, I think we've wrapped it up for today. I think we've had a great conversation. I've given the summary of what I think. Back to you, Priya.
Okay, great. Thank you so much, Paul, and thank you so much to the rest of the panelists. Thank you. This was really a very, very insightful session. But we're not done yet. We still have the Q&A round, and I see that we have a great audience today, and we have a lot of questions. So let's make it interactive. So our first question is, how does Delta Lake compare with Apache Hudi or Apache Iceberg? Does Delta Lake use a lot of excessive storage, as the files are immutable, and it creates and stores different versions of the same file every time something changes? So this is a question from Nishant.
I think I can take this.
Sure,
So Delta Lake, absolutely. So the question here is, what are the advantages of Delta Lake as compared to Hudi? Or maybe if you look at, there's another framework out there, Hive Asset, right? So all these technologies are actually very critical. Like 3 years back, they came in and they were really important when we talk to provide that management and performance layer on top of your data lake and the governance piece of it. So Delta Lake specifically works in a very different way than say Apache Hudi, is that there are multiple layers we can go into. First of all, it provides a lot of management features. So when you talk about governance, one of the key features that I have features that many of the organizations look for is the version control of your data. So if you have a data that is changing over time, the time travel capability of the Delta Lake gives you the ability to store the history of any change that is happening over time into your data set. Now, it is true that you are storing more files because it is writing all the changes into a it creates a new version of your data, but it also comes with management features like vacuum and optimize, which essentially takes care of compacting all the small files into one big file. And if you don't want to have those multiple versions of your data and you don't need them, you can simply run the vacuum command and only the latest version of your data will remain into your Delta Lake. So it doesn't mean that you have to always keep those data records in your storage and pay for them over time. Now, another aspect there is you can actually take this old version of your data and move it to a cold storage. And then like partition scheme in the past, you must have seen that you have some partitions which are present right now. You just read the latest version of your data, whereas anything that is over certain days, maybe 40 days, you have lifecycle control and you move them off to a cold storage. So that's how you can manage the cost, if that's your question. There.
Okay.
Yeah, I'd like to add on to that question as well. I mean, This is typical from an MPP environment. So in a multi-processing, massively multi-processing environment, this is exactly what you do. So in essence, what's happened here is we're utilizing the capability of pure MPP architecture in the cloud versus SMP. So this is exactly how we manage, as an example, how we manage our on-premise a high-speed net warehouse at Nedbank. So it is most definitely utilizing and following the principles of an MPP platform.
Okay. Thank you, Debu, and thank you, Paul. The next question is, which query language is preferably used in data lakes? I think it should be data lakehouse, maybe.
We can.
I can give a stab. I don't know who's. I can give a stab at it. I think on the back of that, again, I think any query language that utilizes, coming on the back of what I was just saying earlier around MPP, any query language that can interact properly with an MPP device would be beneficial. Now, what I say proper, SQL is not a great one for this type of environment. Unfortunately, data scientists, as SQL is limited to one CPU constraint in its query language. So that does limit you. Doesn't give you the maximum benefit. So you should be using query languages that are able to scale in a multi CPU environment. That can shard properly in a multi-CPU platform environment. But unfortunately, SQL, if that's your question, is no SQL, or SQL is not exceptionally good at this, unless you're using Postgres SQL. But the normal SQL is going to limit you in this space. But any other language or scripting language that can handle multi-processor queries would be useful.
Yeah,
actually,
let me also add to answer given by Paul. Generally, people are using. I mean, I have used Scala SQL APIs, Databricks SQL APIs. People are using Java and Python also, because if you have to combine machine learning and AI, your Python data frames and pandas and everything will also be helpful. So to answer the question in a most brief manner, SQL, Scala, Python, and Java all are used with Delta Lake.
And just to add to that, right, recently Databricks actually GA'd SQL endpoints, which essentially have won the TPCDS world record, right? They were 2.2 times faster than the existing data warehouse. So actually now we are at a scale and level that the technology has been improving. We are not targeting sub-second latency, but still you can see that a single data lakehouse, a single layer of truth for your data as can serve all your different workloads. For example, SQL, and as we heard that you can use Python, Scala, R, whatever languages you would prefer.
Okay, thanks, Debu. The next question is, what kind of data models can be used for startups? Currently, they are relying on normal DB to get required data and to process and publish. Are we still using Microsoft Excel?
Let me take this question. I think I had the opportunity to work with several startups. I was associated with one of the largest Google partner, so Google Cloud partner. What is happening with startups is most of the startups are exploring, either Amazon or Google. So when they go on Google or Amazon, they can use, let's say BigQuery is used as a general purpose data store on the backend. And there are several other Google certified data stores. So Google Spanner is there. There are tons of other products on AWS and Azure. So startups are going way beyond Excel. From day one, they are ensuring that data is stored well, data is analyzed well, because for them to show it to customers, for their internal stakeholders, for venture capitalists, they have to have usage data available in an analyzed format. a BI format as well as AI and machine learning format at all times, and that's where they are using all these. They are using new stores like, document stores like MongoDB. All of them they are using from day one, and they are definitely moving away from basic tools like Excel and so on.
Okay. Thank you, Akash. What kind of data goes into the lakehouse? Is it unstructured, semi-structured, and which will be the best in terms of performance?
I can take this question. So I think everything will go into data lakehouse, structured, semi-structured, unstructured data. So that's a main advantage of data lakehouse compared to traditional data warehouses. So it is very challenging to retrieve the data or store the data in unstructured data into data warehouses. But in data lakehouse, you can store all type of data.
Okay.
And just to add to that, before, Raghu also mentioned in his talk that there are various optimizations that are available at the lakehouse level now, like co-locating your data inside your files, indexing, like caching at the that performance layer itself, like Delta Lake has its own caching that is available, and the different types of vectorized engines like Photon, which is completely rewritten in C++ to process your queries in a very fast manner. So all these optimizations are actually making sure that even with your structured or unstructured data sets, like whether they're working on SQL or you're working on your machine learning use cases, all of them are optimized.
Okay. Thank you, Debu. What is the future of BI tools? We can't see many options as Power BI and Tableau are top from past several years. Why are we not seeing new tools or new fabric there?
Let me take this question, Priya. So Google has launched Looker, and Looker has its own markup language. It allows you to effectively embed machine learning and the basic functionality provided by Power BI and Tableau together. And Looker leverages Tableau's semantic layer also. So you could have a lot of assets written in Tableau, which could be leveraged by Looker. And Looker is the next generation tool for high performance data visualization. It also helps you in embedding a lot of machine learning.
Okay, thank you, Akash. Can Hive, Presto, or Trino over a data lakehouse with reasonable practicing compete with the data lakehouse? I guess they support transactions now. That's the question.
So I can start with this one. So essentially, when we talk about the lakehouse, right, one of the benefits of using lakehouse or a single platform, like a unified platform, is that you don't have to use different technologies to query your data, right? So for example, I can talk in terms of Databricks, like in or even if we go 10 years back, right, the Netflixes of the world or Airbnb or Uber, what they were doing is they were building a single platform that went all the way from data engineering to data analysis to machine learning and productionizing all of it. So they didn't have different technologies like that or platforms that were powering these different use cases. So they managed it and they simplified it. So it's all these technologies that you mentioned, they are really great. However, you will still have to manage them and tie them all together. And most of the time, I see enterprises not having the resources or the engineering capability that these companies have. So that's an additional operational overhead that you may have to worry about if you try to build something on your own like that.
Okay. So I think we're almost at the end of the session, but if every panelist could kind of have a closing remark, maybe just 1 minute each. How about we start with you, Debu?
Sure. So thank you, Hebo team, for bringing this event together. And it was really a pleasure. And remember, everyone, like Data Lakehouse is it's a technology, it's a paradigm. it will take some time to get used to, because if you're coming from the data warehouse world where everything was relational and where you didn't consider videos, audios as your source of data, like data lakehouse actually unlocks a lot of potential. So if you need any help in working with how to get from your existing data lakes or data warehouses into the lakehouse paradigm with best practices, reach out to us. Like, we are happy to help and we can get you there.
Okay, thank you, Devu. Raghu, how about you?
Thanks, Hebo team and Priyanka, for giving this opportunity to talk. And I would like to mention one thing, right? When you are moving to data lakehouse, do your due diligence, like do a POC on the data lakehouse before you switching, and define your ROI analysis and present that, and bring all the groups together to understand the value of moving to data lakehouse, and train your people on the new technologies to access the data, and never take a big bang approach. Do it in a phased manner.
Okay, thank you, Raghu. You can see that our audience has a lot of comments. They say great session, very informative. So thanks, audience. You've also been great. Akash, may we have?
Yeah, thanks, Priyanka, and thanks, Paul, also for moderating this session. My little bit of, I will not say advice, but from whatever experience I have seen, data lakehouse are here to stay, and that is really certified by somebody like Bill Inman. Bill Inman created the data warehousing industry virtually. He was the only thought leader in those days, and there were a lot of other guys joined. Now, if Bill Inman can write on Lakehouse, I think this will have a long tail. Now, there will be newer combos and newer architectures coming in, but the basic principle of Lakehouse, where you are combining data warehouse and data lakes, unstructured and structured data, asset properties, streaming data, better data governance, ability to do analytics and machine learning and AI in on one data store, all of those are directly beneficial. So every company is now going to, as Raghu also mentioned, they will not go for big bang approach. They will look at very high impact use cases in AI and machine learning, create a small data lakehouse. And if that gives good results, financially, business-wise, technologically, companies will go on adopting, more and more data lakehouses.
Okay, thank you, Akash. How about you, James? Closing remarks?
Yeah, I'll just reiterate what Paul said before. There are always trade-offs. So if you're looking at data lakehouse, just be aware of those trade-offs. Like, you won't get query speed as fast as an MPP machine, the role of security, column of security, the complexity of having a file folder-based system, missing features in relational database like referential integrity. And sometimes people are just used to a relational database and they're used to writing everything in T-SQL. And now they have to use a slightly different version of SQL that could cause a lot of issues. If you are aware of all those concerns and you're fine with all of them, then a data lakehouse may be perfect for you, especially if you combine it with a product like Power BI. I'm touting a little Microsoft here, but Power BI could, by importing the data from a data lakehouse, and this is what I see a lot of customers doing, is you can get that role of security, that millisecond response time, high concurrency. So there are a lot of options, and no one shoe fits all. So be aware of all these products and how you can combine them to make the best solution for your particular use case.
Okay, thank you, James. And Paul, the moderator, if we can have some closing remarks.
Yes, thank you very much. I think we did an awesome job today, and thanks to the panel and yourself, Pri. I think it was great. And yes, my closing remark is similar to James. Be very careful. There isn't, in my 30 plus years, there isn't a solution that solves all problems. Understand your requirements, understand how you want to use it, understand your benefits, and more importantly, like James has just echoed, understand the trade-offs you make, because all architectures come with trade-offs. Okay, so just remember that. And we mustn't all run out there and build data lakehouses without, because that's the next. It's just another tool in the toolbox of the data enterprise, and how we use the tool depends on the use case. And all companies are different, all industries are different. So just be very careful of implementing something you don't understand just because it's a trend. Make sure you understand the trade-offs, the pros and cons. And that's very similar to James. I think that's my cautionary warning.
Okay, so thank you so much, gentlemen, for this very insightful session. The audience has definitely learned a lot, and thank you, audience, for all your comments and all your questions, and for making it so interactive. Thanks again to all the panelists, for their time and for putting in these points and for sharing your knowledge and your insights with all of us. Thank you very much.
Thank you.
Pleasure. Thanks all.
Bye.
Thank you.
Take care.
Thank you so
Thanks,
much.
everybody.
Bye.
So if you have any questions or comments about this webinar, please write to us at events@hebodata.com. And if you want to know more about Hebo, then please do visit our website. You can also sign up for a free trial. So thank you all and have a good day or good evening. Bye-bye.
Thank you. Bye.
Bye.